Hey guys, we are looking at 6-5 today, and you know, as long as you promise no tears, I've got some news for you. This is the last assignment I'm going to give you. All right, so as soon as you get this finished, you are all finished as far as I'm concerned. So just make sure you're checking progress book, checking all the missing assignments, and just getting everything finished to the best of your ability. Finish this year strong. So what I want to look at is this idea of linear programming, and it kind of applies the graphing inequalities that we've been looking at. So we're going to do one of these together. We're actually going to, you're going to get a copy of this worksheet. We're going to go through this one together. There's one on the back that you're going to do on your own, but you're going to be completing this on Desmos, all right? And I'll have a link for you on this assignment. So here's the situation. So Zane and Tristan have decided to make the most of this quarantine, and they've decided to create some T-shirts and some hats to make a little money. The T-shirts cost them $7 to make, and they're going to sell them for $13. The hats cost them $5, and they're going to sell those for $10. They've got $1,000 to spend, but they don't want to end up with extra hats and T-shirts, so they've decided to make only 180 T-shirts and hats combined. All right. So how many of each of these should they make to maximize their money? All right. So what we want to do on this is the first thing we want to look at is there's some restrictions to what they can do here. All right. There are some constraints. All right. That's a fancy word, but so let's just use the word restrictions. There's some things that are holding them back here. All right. So one of them, there's a couple things that are holding them back. One is they only have $1,000 to spend. All right. So let's see if we can write an inequality. Now they don't have to spend exactly $1,000. That's why it's not an equation. But they can only spend up to $1,000. Well, how are they going to do that? So I'm going to make T-shirts my X and hats my Y. All right. So T-shirts cost them $7 to make, and hats are going to cost them $5 to make, and they only have $1,000. So how can I write that in an inequality? Well, there's the money they're spending on T-shirts plus the money they're spending on hats has to be less than or equal to $1,000. All right. So there's one of the restrictions that they're working under. Okay. There's another restriction that they're working under, and it's the fact that they don't want to make more than 180 T-shirts and hats combined. All right. So I need to write an inequality for that. Again, it's not an equation because it doesn't say they want to make exactly 180. They could make 175 if they wanted. So that's why we're using the inequality symbols. But if they want to make at most 180 hats and T-shirts, well, again, T-shirts is X and hats is Y. So another restriction here is X plus Y has to be less than or equal to 180. Now again, this one had the 7X because we're talking cost, and it was $7 per T-shirt, and this one was $5 per hat. This is just number of shirts, number of hats. All right. So they've got these two restrictions. All right. It's a system of linear inequalities. All right. So what we're going to do, I think I've got this worked out. So we're going to go. You remember those? All right, good. So we're going to go to this Desmos, and I want to look at what this looks like. All right. So again, I can pull up, this little keypad here, and I'm going to type in that first restriction we had. So 7x plus 5y has to be less than or equal to 1,000. And well, that looks kind of goofy, but we got a completely bad scale here. All right, we're talking going only up to 10 when I know I'm dealing with at least 1,000 here. We'll deal with that in a little bit. The other one was that x plus y has to be less than or equal to 180. All right. There we go. All right. Now, it doesn't look real interesting right now. Now, there's two other restrictions, and these are going to be pretty common here. We don't want to talk about negatives. All right. So another restriction is, hey, I want x to be greater than or equal to 0. And I also want, let me go down on the other line, I also want y to be greater than or equal to 0. we just want to take these negatives out here. Now, it doesn't look real interesting right now, or maybe it looks a little confusing. So we need to zoom out quite a bit. So over here, the minus button here will zoom out for us, and we can start to get a little clearer picture here as I click that a couple times. All right, starting to come into play. There we go. All right. So now what linear programming is now, we're looking for the region that got shaded by all of these. Okay, and so, well, what I'm going to do, just so you guys can see it, I'm going to get rid of everything. I'm going to keep that window. All right, just so you guys can see what's going on here. So I'm going to retype those in. All right, so 7x plus 5y is less than or equal to 1,000. Whoops, 1,000. There we go. So there's that. There's that inequality. Remember, all of these points make that inequality true. The next one was that x plus y has to be less than or equal to 180. All right. So now we're talking, all right, what's got shaded twice? This little region right here, right? Okay. That got shaded by both of those. And then I've also got, well, x has to be greater than or equal to 0. All right. So now I'm talking in this little shape here, and then finally y has to be greater than or equal to 0. All right, so it's kind of hard to see, but the area I'm looking at that got shaded every single time is this little area right here. Okay, now what linear programming says is, we want to maximize our profits here. We want to maximize money, and everything in here is a possibility. So for example, that point right there, I'm going to click right there. And that is, I thought it would give me the point, but it doesn't. Never mind. So let's say these are going by 20s, it looks like. So 40, comma 40. They could make 40 hats and 40 t-shirts. All right, that would be right there. Okay, they could make 60 t-shirts and 40 hats. That would be right there. All right, those are all possibilities that would not spend too much money and would fall under this. But what linear programming says is the maximum amount of money they can make will always be at one of these corners. It'll either be right there, and if I hold that down, all right, so they can make, remember, t-shirts was my X and hats are my 0. They could make 0 hats. I'm sorry, 0 t-shirts and 180 hats. All right. They could make 50 t-shirts and 130 hats. Or they could make, now, all right, it doesn't come out pretty, but let's call that, well, we can't say 143, all right, because it has to be less than. So they can make 142 t-shirts and no hats. All right. So our 3 possibilities, and I'm writing this on the paper, and then we're gonna go back to the paper here in just a little bit. But the point that is going to give us the most money is one of those 3 corner points. All right, and that last one was 50, comma 130. Okay, so let me go back now to here. All right, so what we've got is the maximum is here somewhere. All right, now how do we decide which one of those is going to make the most money? Well, now we come back to this. All right, t-shirts, they're gonna make $13 per t-shirt, and hats, they are going to make $10 per hat. All right, so I'm just going to jot that down here. T-shirts, they're getting $13 for every t-shirt, and they're getting $10 for every hat. All right, so I'm going to make a third column here. So how much money are they going to make? Well, if they make nothing but hats, they make 180 hats and sell them for $10 a piece. That's $1,800. All right, if they make nothing but t-shirts. All right. Now you might be asking, wait a minute, why didn't they go up to 180 here? Well, that was, remember, they've only got $1,000 to spend. All right. So 142, is the most they could make and still stay under that $1,000. But 142 t-shirts at $13 a piece is $1,846. Or they could make 50 t-shirts and 130 hats. All right, 50 t-shirts at $13 a piece. All right, is $650. 130 hats at $10 a piece is $1,300. And I add those together, and it's $1,950. So there is that right amount. All right. So this is, again, this is an example of something called linear programming. All right. It's where we come up with, they're called constraints, but I like to call them restrictions. All right. And, you know, if you have some restrictions and you graph those things, you can maximize profit by making one of the combinations that happens at the corners. All right. Now the other corner actually is down here, but that one's kind of a boring one because that's, hey, well, they could not make any hats and not make any T-shirts, but obviously that's not going to maximize their profits. They're not going to make any money. All right. All right. So what I would like you to do, and I'll explain this on Desmos. All right. But what I'm going to have you do for this sniff sniff final assignment is I'm going to want you to do this problem. Okay, you'll have this with you, and I'm just going to make a real quick two slide Desmos activity. The first slide is going to be I want to see your graph for this. All right. And then the second slide will be your answer. All right. We're talking about making skis. All right. Regular skis and slalom skis. You know, let that be X, let that be Y. What are your restrictions? Write me the inequalities for those. Graph those, and then find me the thing. If they make a $25 profit with the regular skis and a $50 profit with the slalom skis, you know, answer this question: how many of each kind should they make that fits all these restrictions, but also maximizes their profit? Okay. Hey, it's been a great year, guys. Go ahead and finish up strong. If you have any questions on this, let me know. I'll be more than happy to help you. But I will look forward to hearing from you guys. Take care.